As an Android developer, understanding the activity lifecycle is essential. Why? Because if your activities don't correctly respond to lifecycle state changes, your app might generate strange bugs, sometimes confuse your users, or even waste precious system resources. Mastering the activity lifecycle is not just a technical skill. It is key to building robust and user-friendly Android apps. Welcome to this episode. So in this video, we'll learn about activities and intent. In Android, activity represents a single screen in your application. Think of an activity as a page in a book, where each page represents a different screen of your application. So every app has at least one activity, which is usually the main entry point. But apps often have multiple activities to separate different functionalities. Guys, before we continue, take some time to subscribe to the channel, like the video. By so doing, you promote the channel. Thank you. So every activity has what's known as a life cycle. An activity's life cycle can be compared to the life cycle of living things, from birth to death, like the life cycle of a mosquito. The different stages of the mosquito shows how it grows from egg to larva, pupa, and then adult mosquito. Similarly, the activity consists of the different states that an activity can go through from when the activity was first initialized to its destruction. So during its lifetime, an activity transitions through and sometimes back to various states. So the transitioning of states is known as the activity life cycle. So this diagram shows all the activity life cycle states. This state represents the status of the activity. Note that unlike the mosquito life cycle, an activity can go back and forth between states throughout the life cycle instead of only moving in a single direction. Android provides lifecycle methods that correspond to these stages, allowing you to manage what happens at each point. So often you want to change some behavior or run some code when an activity lifecycle state changes. So the activity class implements a set of lifecycle method. So what happens is that when you are running your application, Android invokes this callback method when the activity moves from one state to another. However, you, the developer, can also override these methods in your own activity to perform tasks in response to lifecycle state changes. So it is important to know when Android invokes the callback method and what to do in each callback method. To figure out what's going on with the Android lifecycle, it's helpful to know when the various lifecycles are called. This information helps you identify where things are going wrong in your app. A simple way to determine this information is to use the Android login functionality. So the login enables you to write short messages to a console while the application runs and use it to see when different callbacks are triggered. So when you come to Android Studio, I created a new project calling it Activity Lifecycle Guide. When you come to your main activity, you see the onCreate method. So this, you are familiar with it. From the callback, we realize that we've used the onCreate method. It's actually a required method that every activity has to implement, and it's called once in the life of an activity. Here you set or initialize all your static data. That's why we pass the layout to the set content method. So this inflates the layout and makes it ready for it to be displayed in your application. And remember one thing, anytime you override the lifecycle method, you have to follow it immediately with a super class. This line, and this applies to other methods that we'll be looking at. So let's learn how to log information to the console. To begin with, come to outside main activity class and create a variable, a constant variable. Give it a name of tag and assign a string of the activity name, main activity. So just after the superclass call, add this line of code. Pass the tag and then the message on create call. So make sure you import the log utility class. So the log class writes message to the log cat. To find the log cat is over here. So this is the log cat. So click on it. And this is your console, and this console, whilst the application is running, it shows messages of what is going on inside your application. When you look at the logcat, it has three parts: the first, the priority, tag, and then the message. So the priority just tells you how much information will be displayed for you. So we have the D for debug, we have V for verbose, W for warning, I for information, and then E for error. So you can choose between this four based on how much information you want. And then we have the tag. That's just like a label we are giving our message so that we can easily identify it. But when we run the application, you realize that the console displays a lot of messages. To easily find your way out, we use the tag to identify our custom messages. So now let's run the application. We can see that when the app ran, there was a lot of messages at the bottom here when you open your logcat. Guys, before we continue, take some time to subscribe to the channel, like the video. By so doing, you promote the channel. Thank you. And the informations here represent the log priority. So when you check here, the priority, we have the E. So this is an error. The D for debug, the W for warning, and then V for verbose. So this one, the I for information. So this is your logcat. So when you are trying to locate your information, make sure you know the log priority that you set for your log message. So once you know that your log message is under debug, then you focus on that area and search. And a more efficient way you can search is making a search over here. So you come to this package column my. Beside it, just type tag colon and then set the name that you gave your tag. So copy the main activity string and then paste here. So this will filter the information based on the one you output. So when you look at it carefully, you see that we have our log message with the log tag main activity, and when you come here, you see our message called on create. So this is the message that was printed when the activity was being created. So the callback method on create was called. That was when you initialize the app and then it's going to this stage. When it is going to this stage, the onCreate callback method will be called to trigger the app to get to the onCreate stage. So we've seen that. Let's try to see the onStart method. To implement the onStart method, come outside the onCreate method and press Ctrl O or Command O and then type onStart. So in this list, we have all the methods that you can override. So search for onStart. So this is it. You select the onStart. Inside of it, you can log your message. So I'll just copy this one and then paste below here and then change onStart. So I'll say onStart called. So let's run our application again, and you see that after the onCreate, onStart will be called to get to the onStarted stage, and then we have the onResume, onPause in the reverse order. So let's run the application. So when you look at the console, the onCreate was called, after which onStart was called. This shows that the application is transitioning from different stage to the other. It starts from onCreate to first initialize the application, gets to onStart, and then onResume. That is when the application becomes visible to the screen. So let's override that method. Start typing onResume. Then you see this method. You select it and then you can copy your log message, paste there, and then just change it to on resume. So you can copy the function name and then replace it with this. Before we run it, come to your logcat and then clear the logcat. So there's a delete here. When you click on delete, it clears the logcat. So now let's run the application. So this is our log message. So the app went through on create, on start, on resume to become visible on the screen. That's where the app become actually visible onto the screen and the user can interact with it. And then we have the opposite method that tears down the application. So let's implement the rest of the callback method. So now we can use the log messages there. So let's run the application, then we see. So as the application is being launched, the on create, on start, on resume is called. So you ask, when is on pause, stop, and destroy call? The on pause is called when the activity is partially hidden. So in the instance where another application comes to obscure your activity, that's when the on pause is called. So when the application launched, the on create, on start, and on resume was called. To trigger the other tear down method, we have to first, to get it on pause, we have to obscure the screen. So to do that, just select the overview. You see the on pause was called, and then on stop was called, but on destroy was not called. The application, when you open the application again, you see that on start and then on resume was called. To see when on destroy was called, you can rotate the screen. When you rotate the screen, it was paused, stop, destroyed. So on destroy was called when you rotate the screen. It means that the activity died and then was recreated, and it started all over from on create up to maturity, which is the on resume. So you have to know when and how to respond to this callback method or the state changes of an activity. Other things that the user can do that can cause the activity to be recreated is when you perform configuration changes. So the rotation is an example of configuration changes. When the user change the language, and then when user change theme from light theme to dark theme, that one also causes the application to be recreated. So understanding the life cycle helps you to manage resources efficiently and provide a smooth user experience. For this video, I just want you to be aware of the fact that activities have life cycle, and like life cycle of living things, they go through several stages or states. As the user starts the application, navigate between activities, navigate inside and outside of your app, the activity state changes. So we can dive deep into this life cycle topic where we'll talk about better ways to handle life cycle related issues, but they are beyond this course.